how to combine particle systems with custom graphics and make them interact together. Today we learn about rotation, motion patterns, and sprite animation. The full playlist is linked below. Let's go! I want to make the whale sway up and down as it swims. I give it this.angle property. Initially, I set it to 0. VA, velocity of angle, will determine by how much will the angle increase per animation frame. I give it an update method. Inside, I will increase angle by VA. So we have an ever-increasing angle value that increases by 0.01 every time update method runs. For most of us, that's 60 times per second. Now I want to update vertical position of the whale. I want it to sway up and down around the middle of canvas, so this.effect.height times 0.5, and then we add a sine wave, math.sine, and I pass it that angle value. When you pass an ever-increasing angle value to math.sine, as the angle increases, this method will map those values along a sine wave shape, like this. I will call this new update method from inside handle particles to make sure it runs 60 times per second. By default, the sine wave will go between -1 and +1, very small value range, so we can't really see it. I need to increase the radius of the wave by multiplying that value. Now we can see some movement. As we increase this.angle value, math.sine is automatically mapping that ever-increasing value on the sine wave, and we are magnifying that range by multiplying it by some larger value. I can make it relative to canvas height, I guess. Or I can create a separate property I call curve, and then use that here. I also have to make sure that this value gets recalculated every time canvas changes size. All the effects in this series need to be fully responsive, like this. If you console log this.angle, you will see it increases endlessly. It would have to run for a very long time before the value becomes large enough to actually cause any noticeable performance issues, but still, to keep our code clean, let's say I don't want to have an ever-increasing value in my code. I want to periodically reset it back to 0. But when? I say if this.angle is more than 1, set it back to 0. You can see that doing this resets whale position rapidly when it's mid-motion. We don't want that. We have to understand that math.sine is taking this angle value in radians, and we know that half circle is equal to math.pi, approximately 3.14 radians. If we reset every time angle reaches math.pi, we get only half the motion, and then it resets and it goes again. To get the full curve that goes into positive and negative values, I have to reset after math.pi times 2. We reset now. That wasn't even noticeable. It looks like a continuous motion loop because we are resetting at the point when the whale is back at the starting position. Again, we reset now. Perfect. We are resetting angle value. It's not increasing endlessly and we still get uninterrupted motion. What if I also want to rotate my whale up and down as it moves to make sure its nose is pointing towards where it's going? This is a very easy thing to do if you understand how canvas rotation works. I'm going to assume you don't understand it and that you don't know why when I pass angle to rotate, this mess starts happening. Rotation on canvas works completely different than rotation with CSS. Let me explain. First of all, we are rotating the entire canvas element, everything that is drawn on canvas, including the whale and all the particle stars. This shows really well how rotate method is additive. It just adds up when we call it over and over again for each animation frame. To restrict any changes to canvas state to a specific set of draw calls, I will wrap this part of code in save and restore built-in methods. Doing that will make sure that this rotate call only affects this draw image and nothing else. I want the stars to remain unaffected. Now we can see that the whale is being rotated around the top left corner of canvas, around coordinates 0, 0. Think about this point as the default rotation center point. When I want the whale to rotate around its own center, around its current x and y coordinates, I have to set those as the rotation center point by passing them to built-in canvas translate method. So here I am setting this.x and this.y, the current position of the whale, as rotation center point, and everything drawn after that will consider this.x and this.y as if it was coordinates 0, 0 on canvas for all intents and purposes. For that reason, I have to remove them from here. We don't want to double them. Position of the whale is already defined while translating here. This is the confusing part, so bear with me. We will get this to work and then we will recap how it works step by step. I will comment out the sine wave motion for a moment. Now the whale is rotating around its own center point. I want to turn rotating motion into repeating back and forth motion so I can actually pass rotate sine of the angle. This is what it does. I am basically passing rotate method a series of values that gradually cycle between -1 and +1 because of the ability of sine method to convert an ever-increasing range of values into a repeating range that cycles between -1 and +1. I uncomment vertical movement code and we get this. I'm sure this would work for some effects, but it doesn't look like the whale is swimming, is it? Lucky for us, this is a super easy fix. I just put cosine here instead. The relationship between sine and cosine will work perfectly for this. Notice we are passing sine and cosine the same increasing angle value. I could just turn this into a Flappy Bird game now. If I use both cosine, this happens. Or I swap sine and cosine. Alright, we need cosine here and sine here for this particular project. So, two things to remember. If you pass sine or cosine an angle value that slowly increases, these methods will map this ever-increasing set of numbers on a wave, endlessly cycling between -1 and +1. If you want this wave for movement, attach it to position of your object and maybe multiply it by some larger radius, because range between -1 and +1 in terms of pixels would be barely noticeable. The second thing we learned is that canvas rotate method rotates around coordinates 0, 0 on canvas under any circumstances. 0, 0 is always the rotation center point, so if you want to rotate your object around its own center point, first you have to translate coordinates 0, 0, the rotation center point, over that object, and then you call rotate, and then we draw that object at coordinates 0, 0, because the position of that object becomes defined by translate. It's a lot to take in, but don't worry too much. If you keep coding with me, it will become easy. This is a very common technique and repetition leads to mastery. For now, I want to focus on more fun aspects of this project. Let's bring our intergalactic space whale to life. Let's replace the static image with a sprite sheet and learn an easy way how to animate it. In the resources section below, you can download image I called whale2. I bring it into the project here. ID is whale2. And we set this.image on whale class to whale2 like this. This is a different type of whale. It doesn't have a flame propeller for a tail like a spaceship. I made multiple different versions for you. DrawImage method expects 3, 5 or 9 arguments depending on how much control we want over the image we are drawing. Right now we are passing it just 3 arguments, the image we want to draw and x and y coordinates where to draw it. We are also offsetting it by a half of width and a half of height, so we are looking at the middle of this long, wide sprite sheet. Sprite sheet is a single image file that contains a set of individual frames. We can animate it by cropping just a portion of the image, and as we travel over the sprite sheet, cropping out different parts, we get animation. To effectively navigate around the sprite sheet, cropping out frame by frame and create animation, we need to know the width and height of individual animation frame in that particular sprite sheet. I created this sprite sheet for you so I know that sprite width, the width of a single frame, is 420 pixels. We can also calculate sprite width by taking the width of the entire image and dividing it by the number of columns, the number of frames per row. Sprite height is 285 pixels in this case. So let's pass drawImage optional 4th and 5th arguments for width and height. And I want to draw it at coordinates 0, 0 because we are translating to this.x, this.y here on line 67. So this is the second version of drawImage method with 5 arguments. We can stretch the image like this by passing it different width and height values. Right now, we are squeezing all 38 frames of the sprite sheet into an area of 1 frame. For clarity, I will comment out this line and this line as well temporarily, just so we can clearly see what's happening. So we are translating coordinates 0, 0 from the top left corner to this.x, this.y of the whale. We do that to make the rotation work. Then, from those translated 0, 0 coordinates, we are defining width and height of the entire sprite sheet to be 420 times 285 pixels. To animate the sprite sheet, we need to use the longest version of drawImage method that accepts 9 arguments. This version gives us the most control over the image we are drawing, and it's important to understand it if you want to animate sprite sheets or if you want to build 2D games. We need to pass it 9 arguments: the image we want to draw, source x, source y, source width and source height of the area we want to crop out from the source image, and destination x, destination y, destination width and destination height to define where on destination canvas we want to place that cropped out piece of image onto. So first, let's just crop out the left frame. So cropping area will go from coordinates 0, 0 on the sprite sheet to sprite width and sprite height. Okay, we are cropping out this frame and we are drawing just that frame on canvas. Again, if I want to center it, I need to offset destination x and destination y arguments by a half of sprite width and a half of sprite height. We can now animate it by jumping through the sprite sheet frame by frame. We will do that using a helper variable I call, for example, frame x. Initially, I set it to 0. I will also need to define max frame. When frame x reaches max frame, it will reset back to 0 so that it can cycle through all those frames again. Source x argument allows us to navigate around the sprite sheet horizontally. By pushing the starting x and y position of the cropping area around, we define which area, which frame is being cropped out. I do it like this: 0 times sprite width is 0, so that will crop out the left frame. 10 times sprite width will move the cropping position here, and now we are cropping the 10th frame. So let's make this dynamic and replace this value with our helper frame x variable. We know that as this number increases, we are cropping out different area of the sprite sheet. So when frame x is 0, we are cropping this frame. When it's 1, we are cropping this frame, 2, 3, 4, and so on. Now I just need to make sure that frame x endlessly cycles between 0 and max frame. Here I'm using a ternary operator. I'm using it as a simple one-line if-else statement. If frame x is less than max frame, increase frame x by 1. Else, meaning it's more or equal to max frame, set frame x back to 0. And we are animating. So ternary operator used as a simple one-line if-else statement. Expression to evaluate, question mark, if true, do this, colon, else, do that. This is how you animate sprite sheets in JavaScript without using frameworks or libraries. It's a very common and useful technique. I use it in many different projects. I uncomment the up and down motion, and I will also uncomment rotation. Notice that we are increasing frame x by 1 for every animation frame here. This means that the frames will cycle at the maximum speed. Because we are controlling animation using built-in request animation frame, this means that animation speed automatically adjusts to screen refresh rate. For most of us, that's 60 frames per second. On high refresh rate gaming screens, it will be much faster, and this animation probably moves too fast for you. What if I want to get more control over the animation, and I want to make sure each frame stays on the screen for a set amount of milliseconds, meaning that the sprite sheet will animate at the same or similar speed on all different machines? How to manually control FPS and how to use milliseconds to time and trigger periodic events, such as serving another animation frame every 16 milliseconds, for example. We can easily do that with timestamps and delta time.